In this video lecture, we are going to solve next questions from Airfield chapter in Keith Williams' performance book. Very important chapter as far as takeoff distance available, accelerate stop distance available, clearway, stopway, these concepts are concerned. So let's look at these questions one by one and answer them. So the first new question, which of the following equations is true? Takeoff distance available equals to takeoff run available and clearway. Takeoff distance available is clearway plus accelerate the emergency distance available or accelerate stop distance available. Takeoff run available is takeoff distance plus stop way. Accelerate stop distance, takeoff run and clearway. So remember, you will have to remember this diagram, whatever helps you understand the concept. Now first things first, takeoff run available, TORA, takeoff run available. So this is the available runway length, okay, runway length available for takeoff, okay, for conducting your takeoff roll and takeoff purpose. Okay, so takeoff, you can use this entire length of runway for your takeoff. So that's why this entire length of the runway will be called TORA or takeoff run available. But now since this is a displaced threshold, for landing purpose, you will not use this entire length of the runway. You will use that length of the runway beginning from the threshold. So landing distance available starts from this threshold and ends at the end of the runway. So remember that. If there is no displaced threshold, in that case, takeoff run available and landing distance available will begin from the very start of the runway. Both will be equal. Next thing, stopway. This stopway, or over here there is a stopway. What is stopway? The purpose of the stopway is to stop aircraft, any aircraft which has aborted its takeoff roll on the runway. So there is a speed called V1 speed. At this speed, if you cross this speed or if you pass this speed, you should continue your takeoff roll and take off, lift off. Uh, at, at this speed or under this speed, you can decide to abort your takeoff roll and stop your aircraft within the available runway distance. If that's not possible, you can exceed or you can uh, cross or go beyond this runway and stop your aircraft in this portion called stopway or in an area called stopway. So that is the purpose of the stopway, to stop your aircraft immediately in that area. Okay, now takeoff run available, this runway length available, which is takeoff run available plus stopway, is equal to accelerate stop distance available. Takeoff run available plus stopway equals to accelerate stop distance available or emergency distance available. Next is the concept of clearway. What is clearway? Clearway is an imaginary area that begins from the end of the runway and ends at the point or ends where the first obstacle penetrates your flying path. Okay, at the point of first obstacle. So clearway beginning from the runway to the point of first obstacle. Okay, near takeoff flying path. So that is your clearway. Now what is the formula for clearway? Takeoff distance available is equal to takeoff run available plus clearway. Okay, so takeoff run available, the entire runway distance plus clearway, okay, plus this clearway equals to your takeoff distance available. Okay, so this two formula you must remember. Take accelerate stop distance equals to runway plus stopway. Takeoff distance available equals to runway plus clearway. Fine. So over here, which of the following equations is true? Takeoff distance available equals to takeoff run available plus clearway. Yes. Takeoff distance available equals to clearway plus EDA. No, it should be takeoff run available. Takeoff run available is TODA plus stopway. No, takeoff run available is nothing but available runway distance, available runway length or declared distance. Accelerate stop distance available is takeoff run available plus stopway, not clearway, it is stopway. Next, question number 32. So read this. Takeoff distance, distance from the point on the surface at which aircraft can commence its takeoff run. So, a point on the surface of the runway from where you begin your takeoff roll, uh, to the nearest obstacle in the direction of takeoff. So, takeoff distance available from the point you begin your takeoff roll to the point where the first obstacle falls in your takeoff line path or takeoff path. So, it's nothing but this runway length, which is takeoff run available plus clearway. Next is the takeoff run is from the start of the takeoff run to the end of the runway, and the clear way is from the end of the runway to the first obstacle. So clear way begins where the runway ends, and it stops or it ends where the first obstacle appears in your takeoff path. Takeoff distance available is therefore takeoff run plus clear way. The definition is included in ICAO Annexure 14. Next, when taking account of runway alignment reduction, what must you do? The reduction in takeoff run, takeoff distance, accelerate stop distance are the same. The reduction in takeoff run is greater than the reduction in takeoff distance and accelerate stop distance. The reduction in takeoff distance is greater. The reduction in accelerate stop distance is greater. Now, what is runway alignment reduction? Runway alignment reduction. This is the runway uh, available at your airport for takeoff. Now, when all your aircraft complete their taxi and as they enter this runway to line up with it and begin its takeoff roll, it will not line up with this runway at the very start of it. Okay, if the runway starts somewhere here, no aircraft will go up to that corner of the runway and line up at that edge of the runway. It will taxi the pilot will taxi aircraft on the runway and consume some initial portion of the runway as it tries to enter aircraft on the runway and line up with the runway center line. So this whole process will consume some part of the initial portion of the runway. So that initial portion, meaning what will be the outcome of that or what will be the consequence or the result, the initial portion of the runway, this portion of the runway won't be available for your takeoff roll, for conducting your takeoff roll, right? So that much part of the runway, or very small part still, that much part you have lost. You cannot use that part to conduct your takeoff roll, accelerate your aircraft. So we have to take account. So if the runway distance or if the takeoff run available distance is equal to, let's say, 1000 meter, 1 kilometer is 1000 meter, okay, and you are consuming the initial 100 meters. So out of the total 1000 meter, you are consuming the initial 50 meter in maneuvering your aircraft, lining it up with the runway center line. So what is the actual runway available at your hands, available for you to conduct that takeoff roll? The remaining 950 meters, right? The remaining 950 meters. So although the runway distance or the runway length is 1000 meter, you're not going to use the all of it. Okay, you're only going to use some part of it, that is 950 meters. The rest 50 meters was used in aligning your aircraft with the runway center line. So this is called runway alignment reduction. Now there are small aircraft, light aircraft, medium size aircraft, okay, uh, large size aircraft, right? Now this small aircraft will not consume much, uh, a large portion of the runway in lining themselves up with the runway center line. But some large aircraft like Boeing 747, Airbus A380, or wide body aircraft will definitely use will definitely use some initial portion of the runway in lining themselves up with the runway center line. Okay, so the initial portion will be lost or won't be available for that takeoff run. So we have to take into account these factors in our flight planning, performance planning as well. So this concept is called runway alignment reduction. The reduction in the runway length in the pursuit of aligning your aircraft with the runway center line. So what happens now? There are two things. We have something called takeoff distance available and accelerate stop distance available. The takeoff distance available is takeoff run available plus clearway. Accelerate stop distance is takeoff run available plus stopway, right? So these two things. Now, accelerate stop distance includes stopway, right? Now, what is the purpose of this stopway? To stop your aircraft in that stopway area without the nose wheel of your aircraft going outside the runway or outside the limits of that stopway area. Okay, so the entire aircraft must stop in that stopway, including the nose wheel and the main wheels. Okay, so stopway, I'm writing here nose wheel. And what is takeoff distance available? It includes clearway. Now takeoff distance available means you're going to conduct that takeoff roll. You're going to lift off and fly in the atmosphere. So the liftoff is completed when the main wheels of your aircraft leave the ground. So as far as takeoff distance available is concerned, main wheels. Accelerate stop distance available, nose wheel. Now your aircraft, let's say this is your aircraft, okay? It has this nose wheel, it will have this main wheel. Now when you are considering accelerate stop distance available, you have to consider the nose wheel, okay? The distance the nose wheel covers the runway, okay? So this much part, as far as clearway is concerned or takeoff distance available is concerned, you're only concerned about the main wheels of your aircraft. So you need not account for or consider this much distance, which you will do in case of accelerate stop distance available. So in case of takeoff distance available, just the main wheels part, okay, just the main wheels part. So that's why accelerate stop distance available. The runway alignment reduction will be more for accelerate stop distance available compared to takeoff run available or takeoff distance available. Okay, so remember that option delta is the right option. Okay, so runway alignment reduction, the reduction in accelerate stop distance is greater than the reduction in takeoff run available or takeoff distance available. Okay, because for accelerate stop distance, we must stop that aircraft, the whole of that aircraft, including nose wheel and main wheels, in the stopway area. So we need some extra space or extra runway available or area ground available to account for that nose wheel as well. So, so rules require that published distances available be reduced by the amount taken by aircraft to line up with the runway. This is termed runway alignment reduction. Takeoff distance available, takeoff run available are related to the distance available up to the point main wheels lift off. So the alignment reduction is taken from this point on aircraft. Accelerate stop distance is concerned with the distance available to stop aircraft without its nose wheel going beyond the limits or running off the stopway. Okay, that's why runway alignment reduction is greater for accelerate stop distance than for takeoff run available or takeoff distance available. Next. Okay, so it's very important that you understand the concept of runway alignment reduction. When taking account of runway alignment reduction, the accelerate stop distance is taken to commence at nose wheel position, main wheel position, C of G, center of gravity, or nose position. So just now I explained, accelerate stop distance is taken to start from the point of your nose wheel position to the end limit of your stopway. So let's say this is your runway and this is your stopway. Here is your aircraft. the runway. This is the nose wheel. These are the main wheels. So accelerated stop distance available will begin from the measurement will begin from the nose wheel of this aircraft, the end of the runway. Okay. So you will have to eliminate in order to calculate accelerated stop distance available. You will have to eliminate this much distance. If the entire distance, the total runway distance is 1000 meter, you will have to eliminate, let's say, initial 100 meter. So remaining runway distance takeoff run available distance is only 900 meter. Let's say stopway distance is another 300 meter. So what is accelerate stop distance available in this case? It is 900 plus 300, which is 1200. So this is more accurate. Now, in exam purpose, you will not have, they will not give you any runway alignment reduction factor. Okay. So just for exam purpose, if they ask you to calculate accelerate stop distance available, you will add this entire runway length of 1000 meter and this stopway. So 1000 plus 300 will be 1300. But when the concept of runway alignment reduction is introduced, you will uh, be more specific. Okay, you will subtract this 100 meter used by aircraft in lining itself up with the runway, and you will only add the available runway distance out of the total 1000 meter, which you can actually use for the purpose of takeoff roll. And that 900 plus 300, so 1200 meters. Okay, so depends question to question. So correct answer here is nose wheel position. Next. Taking account of runway alignment reduction for takeoff distance available, which is takeoff run plus clearway. Now this distance will start at main wheels position. Okay, it will start at main wheels position. Similar, same concept. So let's say for accelerate stop distance available, we started our measurement from the nose wheel. For takeoff distance available, we will start our measurement not from the nose wheel, but from the main wheel. So we have some extra margin. So instead of starting from here, we will start from here. So we have this extra distance available for that takeoff roll, and this, and yeah, that's it. So let's say this is 900, and this small part is another 330 meter. So total distance available for takeoff run is 900 plus 30, that is 930 meter. Let's say this is your stopway, both stopway and clearway. It can happen that both stopway and clearway are coinciding. In that case, this will be 300 meter. So takeoff distance available will be equal to 930 meters plus 300, which is 1230 meters. So you can see takeoff distance available 1230, and previously we calculated accelerate stop distance available equal to 1200 meters, right? So accelerate stop distance available ka reduction is more than takeoff distance. Okay, this is 1230, it is 1200. So this is the concept. I hope you have understood this. So for takeoff distance, main wheel. When taking account of runway alignment reduction, the takeoff run is taken to commence at nose wheel, main wheel, center of gravity, nose position. So takeoff run, same, main wheel position. Both takeoff run and takeoff distance begin from main wheels. Okay. It is only the accelerate stop distance available which begins from the nose wheel. Takeoff distance available is what? Now takeoff distance is takeoff run available, that is runway distance available plus clearway. So runway plus stop runway, no. Runway length is only takeoff run available. Runway plus stopway is accelerate stop distance available. Runway plus stopway plus clearway. Runway plus clearway. So delta. Next. Okay. So takeoff distance is runway plus clearway. Accelerate stop distance runway plus stopway. So next. Increasing ambient temperature will do what? Okay, so this concept is related to density altitude. Now wherever the temperature of atmosphere increases, density of air, concentration of air molecules in a specific volume of air decreases. So we say when temperature increases, it becomes hotter and hotter, the density of air will decrease. When density of air decreases, that air becomes thin air. Even when we climb mountains, the density of air decreases, the air becomes thinner and thinner. It becomes very difficult in difficult to breathe. Okay, similarly, in similar fashion, uh, when the density of air decreases, your engine is unable to produce enough engine power because insufficient air available for combustion, thin air available for combustion, or less dense air is there for combustion. The efficiency is not maintained, and as a result, there is this negative impact on power generation. So that's why we say always when temperature increases, density of air decreases, your engine power decreases. Okay, the engine power production decreases. So that's why if you are climbing from a particular airport where temperatures are very hot, or you are climbing at a very high altitude airport from a mountain, let's say, where density of air is found to be negligible or very thin. So in such scenarios, you are expected to take off, you are expected to take off at lower values, at lower values. Let's say in ISA conditions, in perfect ISA conditions, on that particular day, you can take off with 1000 kilogram. But on such a high density altitude day, unfavorable day, where temperatures are very hot, density of air is very low, or you're climbing or you're operating from a very high altitude airport where density of air is very low. In such conditions, you will be expected to take off with only a mass of let's say 600 kg. So automatically as situation or as atmospheric conditions become unfavorable for your operation, the takeoff mass limitation decreases. On a good, perfect, favorable day, the takeoff limitation expands. Okay, you have more range to carry more payload or more mass in your aircraft. But on a bad day, unfavorable day, the takeoff mass limitation decreases. So now the room available to carry payload or weight or cargo, whatever that is, decreases. You will be able to take off, or you are expected to take off with much less weights. So this is what happens. So increasing ambient temperature will decrease your performance limited or field length limited takeoff mass. What is field length limited takeoff mass? Now there is one fixed available runway distance available. Okay, fixed runway distance available or fixed runway on a very good day, like favorable day where the density of air is very high, temperatures are colder than ISA, high pressure conditions exist, dry runway, good for takeoff conditions. So you will require, let's say there is 1000-meter runway length available, you will be able to successfully achieve a liftoff, let's say within 400 meters, 500 meters, whatever that is. Now contrast this with a particular day that is unfavorable for operations, hot air, very hot temperatures, low density. Okay, runway is wet, humid. Runway is wet. There is humidity in air, atmospheric pressure is very low, you're operating from very high elevation airport. So such conditions, mainly unfavorable, will demand a longer runway length distance to achieve acceleration, momentum, achieve your takeoff speed or liftoff speed, right? So on such a bad day, you will be able to achieve a successful liftoff within, let's say, 700 meters. So automatically, a good day in a small runway distance, you can achieve a liftoff. Bad day, you need more latitude to achieve that acceleration, momentum, that speed to lift off. So this is called field length limited takeoff because when you're doing your flight planning, you're doing your performance calculations, you must take into account the runway length available at your departure airport, runway length available at your landing airport. Okay, so these are field limitations, limitations imposed by the field or by the runway. Again, second factor that influences your performance calculations is the presence of obstacles in your takeoff flight path, right? So that is another thing. So correct answer is option alpha. Decreased field length limited takeoff mass. Okay. Since the available runway distance is not enough or is not sufficient to enable you to achieve a successful acceleration, momentum, achieve speed, you are required to compensate for that by decreasing the takeoff mass value. Okay, by decreasing the mass that you can take off with. Understand it like this. 38. The aircraft classification number landing on newly constructed runway is what? It should not be greater than performance PCN, must never be greater than 125% of it, can exceed performance by 10% without ATC approval, can exceed performance limitation by 10% only with ATC approval. A very important, see, whenever runways are built, are newly built, there is a newly built developed airport, new runway, everything. So now this runway will have its limitation, will have its own limitation, the extent of load or the extent of stress imposed on it that it can bear, that it can withstand without failing. Okay, so that is called performance classification number. Every runway has that number allotted to it, which signifies how much load that runway can bear, how much aircraft's weight or impact it can bear or withstand without getting damaged. So following initial construction is new construction. The load bearing strength of concrete increases over a period of months. So when a runway is newly constructed, you cannot uh, subject it or subject that newly constructed runway to excessive loads. You must give that runway some time, and as time passes by, the load bearing capacity of that runway, the toleration of that runway increases. Okay, so the load bearing strength of concrete increases, very important point, over a period of months. So it's a long time before reaching its maximum value, before reaching its best value. The ability of a runway to sustain, to support the operation of high mass aircraft, heavy aircraft, therefore increases during the first year following its construction. So this ability of the runway will increase with time. Okay, so give time. The compatibility between aircraft and runways is controlled through international agreements using a system of classification numbers. Aircraft classification number is a measure of the load imposed by a given aircraft type. Okay, and pavement classification number, previously I said performance classification, that was incorrect. It's pavement classification number. It's a measure of the load that the runway can bear, the runway can withstand. Okay, so in order to maintain the integrity, okay, or durability of newly constructed concrete runway, the ACN must not be greater than the PCN. Okay, you cannot exceed the stress or you cannot exceed the load bearing capacity of the runway. So during the first 12 months following runway construction. So the correct answer here is the aircraft classification number must never be greater than pavement classification number. Otherwise the runway will get damaged. So option alpha. If the stopway of an airfield is extended to a length equal to its clearway, what will happen? So meaning, is the meaning of this? There is a runway available, takeoff runway available, and we have a stopway at the end of this takeoff runway, and we also have a clearway, but both this stopway and clearway are coinciding with each other. The lengths of both this stopway and clearway are equal. Okay, so when this happens, what will be the end result? Maximum takeoff mass and V1 speed. V1 is takeoff safety speed, the speed at which you make a decision to continue your takeoff roll or abort your takeoff roll. So maximum takeoff mass limitation will increase, V1 speed will increase, maximum takeoff mass will be unchanged, but V1 speed will increase, maximum takeoff mass will increase, but V1 speed will not change. maximum takeoff mass and V1, both of them will decrease. So, okay. So here the question states that the stopway is extended. That means the length of the stopway is extended or is increased. Previously, the stopway was 50 meters long. Now it has been extended or increased to 100 meters. So when stopway increases, what happens to the uh, takeoff mass and V1 speed? So remember, what is the purpose of the stopway? The purpose of the stopway is to stop that aircraft in the event of takeoff abortion, right? To stop that aircraft within the available stopway limits or that stopway area, right? So the longer the stopway length means your aircraft can accelerate to greater speeds, right? When your aircraft accelerates to greater speeds, the momentum will build up. Okay, when the momentum builds up and should something occur, should some unfortunate event occur, and you have to abort your takeoff route, so you will have to cut back engine power, stop your aircraft within the available runway distance or stopway distance. Now this highly accelerated aircraft, high momentum aircraft will require much longer distance to come to a full stop, to decelerate itself and then come to a full stop compared to aircraft which is lightly accelerated or which is whose momentum is not that very high, right? So high momentum objects or heavy objects will require more longer distances to come to a stop compared to light objects or light aircraft whose acceleration speeds are very slow, correct? So whenever you increase the stopway distance, you are indirectly suggesting that the takeoff mass of that aircraft may be increased. If you are taking off with 10,000 kg today, stopway length has increased, so now you can increase your takeoff mass and you can take off with 20,000 kg, for example. Okay, so takeoff mass is increased from 10,000 to 20,000. Aircraft becomes heavier. A 10,000 aircraft will be lighter than 20,000. So now increase in stopway means increase in takeoff mass limitation. When takeoff mass increases from 10,000 to 20,000, what happens? That particular aircraft object becomes heavier. When aircraft becomes heavier, it will take some longer time to accelerate. Heavier objects take some time to accelerate themselves. Once they get accelerated, the momentum will be much more than the momentum of any other comparable object, any other smaller object. Okay, so that when momentum increases, V1 speed will also increase. So the correct answer here is if stopway is extended or increased in length, the takeoff mass limitation and V1 speed, both of them will increase. Why? Both of them will increase because in the event of takeoff abortion, there is sufficient runway distance available, stopway length available to bring that aircraft to a successful halt. That's why. So because of that new stopway length or increased stopway length, we can afford to have increase in takeoff mass, increase in V1 speeds. Only because of that. Otherwise, no. So accelerate stop distance is the distance available in which aircraft can accelerate to V1 speed and decelerate to a stop in the event of an aborted takeoff. The length of the accelerated distance is equal to the length of the runway plus stopway. Increasing takeoff mass reduces acceleration rates. What does this mean? Acceleration rate means how fast you can accelerate or increase the speed of a particular object. Okay, it's difficult to accelerate a heavy object. Okay, a lighter object can be accelerated much quickly, but a heavy object requires some time to accelerate. So hence increases the distance required to accelerate and stop. An increase in stopway length will therefore increase the maximum allowable takeoff mass. V1 is the speed from which it's possible to either continue the takeoff safely or cancel it. The longer the ASDA, the greater the maximum value of V1 speed. Increasing the stopway length will therefore increase the maximum takeoff mass limitation and also increase the maximum V1 speed. The maximum takeoff distance available is what? Takeoff distance is runway length plus clearway. So this is wrong. Alpha is wrong. Bravo is right. Yeah. So takeoff distance is declared runway length plus clearway length. So I hope you have understood all the 10 questions, the explanations I provided. If you have any questions, need any further clarification, reach out to me in the comment box of this video. Thank you for your time. I'll see you in my next video lecture in which I will do the next 10 questions. See you.